Okay, we stopped here last time. Uh, if you remember, I told you that manufacturing process is we classify manufacturing process to two category, which is processing operation, as you can see here, processing operation and assembly operation. Two item. Manufacturing process is two item. That, as we described last time, processing operation. When the processing operation, to remind you, in the processing operation, we start with the raw material and do material transformation. Right? Do you remember that? We start with the raw material. We have raw material and do material transformation. Transformation, geometry transformation, mechanical transformation, everything. So you start with the raw material, you do material transformation, you get the part, as you can see. This whatever we call processing operation. A second item in manufacturing process is the assembly operation. You bring all the part together and you assemble together to have the product. This is the two item in manufacturing. I described that last time, if you also remember. Processing operation is a shaping process, property enhancement, surface processing operation. Shaping process, as I told you, is a four item: solidification, particular processing, which is the powder technology, deformation process, metal removal rate. In these four items here, we shaping the material. Shaping the material, I mean change the shape of the material. So we call shaping the material. So shaping the material, four item, as I described now, and we will discuss now in details one by one. And next item in processing operation is a property enhancement. And the property enhancement, usually in the property enhancement, we improve the property of the part we produce by shaping. So if you remember, I said that shaping is the first step. And after shaping, as you can see, you do property enhancement. You cannot do property enhancement before shaping. Shaping first. So first step, you shape the material. After you shape the material and the material reach to the final shape, you do property enhancement, like heat treatment. You do heat treatment to change the property of the material. So material in a soft phase, we do heat treatment, become in a hard phase, and so on. So this whatever we call it property enhancement. And next after that, which is a surface processing, to protect the surface from the humid environment, from the whatever environment condition, to make the system is adapt with the environment condition. We cleaning, we cleaning the parts that we would like to make surface processing operation. We cleaning first, second we do coating or painting or whatever process to protect the surface. This is a processing operation. Someone said that, is it important to do all this process in the processing operation? Not necessarily. Maybe shaping only, maybe shaping and the property enhancement, maybe shaping, property enhancement and surface processing, maybe shaping and surface only, no processing or property enhancement. It depends in the case. So it different from case to case. So it depends on the case. It depends on the functionality of the part. Right. And next item is assembly. We have a permanent joint and we have mechanical fastening process. Permanent joint like welding, brazing, and adhesion bonding, and all category of welding. And when you do welding, we call it is a permanent joint, and permanent joint because it is very difficult to disassemble again after you do the welding process. Once you did a welding, right, it's very difficult to disassemble again after welding process. Next is the mechanical fastening. Mechanical fastening we use, like here, bolt and nut. This is a mechanical fastening. We use a bolt and nut to assemble the part, so it will be easy to assemble and easy to disassemble. Right. What is the difference? We will discuss the difference between these two and which one is better. We will discuss that here in the next slides in this class. Right, let's go through one by one. We will start first with the processing operation. We will start first with the processing operation, right? This is the first we're going to start with. This is a processing operation. As I told you, processing operation: shaping, property enhancement, and surface processing. These three items: shaping, alter the geometry. When I said shaping, it means modify the geometry of the material, right? If you said property enhancement after shaping. So shaping is the first step to change the geometry of the material, right? Second, property enhancement to change the mechanical properties of the material, physical properties, mechanical properties, without changing shape. Shape already done here in the first step. So when you say shaping, shaping done here. And no more shaping. Shaping done here and no more shaping. So property enhancement, there are no shaping in the property enhancement. It is only mechanical and physical properties. And the next is the surface processing operation. We do cleaning, treatment, coating, deposit material on the surface, painting, and so on. The idea is to protect the surface from the environment, right? Let's just move forward. Start with the shaping. So now processing operation, manufacturing, processing operation, there are a shaping, property enhancement, and surface operation. Now we're focusing on shaping. In processing operation, we will start discussing about the shaping, which is the solidification. 4 items in shaping: solidification, particular processing, deformation process, material removal. We'll start discuss these items one by one. Let's go through how to change geometry. When I say shaping, shaping is to change the geometry of the material. So this is the 4 items to change shaping, or change the geometry of the material. This is the 4 items: solidification process, particular processing, deformation process, and material removal. Actually, let me tell you that this is a subject this semester. This is the item that we're going to discuss later, or to discuss in this chapter. In this subject. This is the item that we're going to discuss in this subject. This is a syllabus actually. Solidification, particular processing, deformation, material removal. This is the item that we're going to discuss in coming classes, inshallah, until the end of the subject. Okay, solidification. Let's start with this one. Solidification. What is a solidification, even in English? If I ask you solidification, what is a solidification? Solidification means something liquid becomes solid. You agree with me? This is the English meaning. English meaning solidification means it was the part was liquid and then become solid. This is a solidification. So solidification refer to liquid states. We call it casting as well. So same meaning, solidification or casting have same meaning. In a solidification, actually, we put the material in a liquid form. Liquid form means we melting the material. So we bring the raw material, we melt the raw material. We put in a furnace, so we melt the raw material. So raw material here is liquid. So raw material here is a liquid form. And we pouring this raw material in a cavity made in the mold. We call this one mold. We put the liquid, we bring the liquid inside certain cavity. This cavity prepared typically with the part that you would like to produce. So the cavity here, the cavity shape, it is exactly have same shape of the part you would like to produce. So we bring the liquid metal. This is metal, right? We bring the liquid metal into the cavity. So the liquid metal fills the cavity, and they get the dimension and the specification and geometry of the cavity. And you leave it for a while until solidification. When it solidifies and becomes solid, you destroy the mold, you take the part out. This is the part. So raw material, we put the raw material in a liquid form. We put the raw material in liquid form. It means that we put in a furnace, we melt the raw material, it's become liquid. فاهمين يا شباب اللي انا بقوله؟ واضح الكلام؟ في اي مشكلة؟
ايوه واضح.
تمام. لو حد عنده اي سؤال او اي استفسار يسالني، نو بروبلم ات اول. مهم، اهم حاجه انك تبقى فاهم. انا بنقول بالعربي، يعني احنا عندنا الرو ماتيريال يا شباب بنعمل لها ميلتنج، بنحطها في الفرن ونعمل لها ميلتنج تبقى ليكويد. بعد كده نصب الليكويد ده زي ما انتم شايفين في كافيتي. الكافيتي ده احنا بنعمله قبل ما نعمل عمليه الكاستنج، والكافيتي ده الشكل بتاع الكافيتي اللي احنا بنعمله ده بيبقى بالظبط هو شكل البارت اللي احنا عايزين ننتجه. تمام. فانت بتحط الليكويد ده، بتحط الليكويد جوه، الليكويد بيفل الكافيتي، يعني يملى الكافيتي ده، فبياخد نفس الشكل والدايمنشن والشيب بتاع الكافيتي، وده الجزء اللي انت عايز تنتجه. بعدين سيب ده يبرد. الجزء ده بنسميه المولد، اللي احنا بنصنع فيه الكافيتي اسمه المولد. بعد كده بتسيبه يبرد، لما يبرد بيبقى سوليد، عشان كده سميناها السوليديفيكيشن. ودي بنسميه الكاستنج بروسيس. تعمل ديستروي للمولد، تيك البارت اوت، البارت ده بقى هو ده البارت اللي انت عايز ينتجه. This is the part here takes same shape and dimension geometry of this one. Yes, Muhammad. You would like to ask? Yes, I'm listening.
Doctor, I would like to ask about the kind of the material.
You said we melt the material, then we put it inside and leave it. Do we need to do something before we leave it, or we just leave it and it becomes solid?
Actually, there are many details we'll discuss later when we come to the casting process. But just like here in this chapter, it's introduction. I don't want to go in the details now, because these details we will discuss in a chapter, casting chapter. So there are many details here, what to do, how to do the cooling and so on. So we will leave it now, Muhammad, right? But just what I would like to let you know that shaping first process of shaping is a solidification, right? Solidification, it means liquid. We bring the liquid, we put the liquid in a cavity, it will solidify. Even if you leave it and you didn't do anything, it will solidify. You understand me? It is temperature of the liquid here is around, for example, 1000 degrees Celsius. 1000 degrees Celsius. Tamam? We put this liquid inside. If you leave it, if you didn't do anything, just leave it inside, what will happen? It will cool down. It will cool down and reach to the room temperature, which is 20 or 25 degrees Celsius, and become solid. Then this is a part, right? So this is first one, solidification. To show you, this is actually the process here. You see this, a metal is liquid. The metal here is liquid. We're pouring liquid in certain pre-prepared cavities, and cavity fills the cavity. Finally, you get the shape of the part. So this is the first process, which is the solidification. Next process or second process is the particular processing. Particular processing, or the particular processing, it is a powder technology. Particulars, they call it particular processing, which is a powder technology. Powder technology, it means that we're dealing with the powder. We use the powder to manufacturing the part. Someone says that, is it possible to use a powder to manufacturing part? Yes, it is possible. How to do that? We bring the powder. It is a powder. What powder? What powder? Powder, metal powder. What metal powder? Any material. Actually, not only metal. Could be metal, could be non-metal like ceramic. Could be metal powder, could be ceramic powder, could be polymer powder. It could be mix between metal and ceramic, metal and polymer, ceramic and metal and polymer. It could be mix. It could be mix of several metal material, for example, aluminium, magnesium, silicon, like alloy, but no melting. We're not going to melt actually. So this is a powder, material powder. Someone will ask me how we create the powder. This is not our focus actually. We're teaching how to bring material in a powder form, but this is in 406. Here in 322, we are not focusing how to bring the material in a powder form. This is not our focus here. But but at the time, I don't want to go in details on how to bring material in a powder. So powder here, we bring material as a powder. We bring this one from the market, and then you bring the powder in 2 steps. To manufacturing the part, you bring the powder in 2 steps. First step is to compaction, to do what we call is a compaction. Compaction means apply pressure. To put in this die, this we call it is a die and punch, and do compaction. You do apply very high pressure. When you do high pressure, atoms come very close to each other, as you can see here. And the next step, you take the part here, you put in a furnace. We do sintering. So compaction and sintering. This is the first step. This is the second step, compaction or pressure. You apply pressure. We call it compaction process. Second step is a sintering. Sintering to put the part, this part, it will be green. When you do compaction, the part will be green. And then you put in the furnace for a while. What will happen? Nucleation will happen, and then diffusion, and then you get solid part, as you can see here. Someone will ask me why we do this. Simply why we don't just simply melt this material and get the part like what we discussed previously, right? In casting or in solidification. Why we have to do this kind of complicated process? You get the material in the powders, and the first step you have to bring powder, and then you do compaction and do sintering, and you do this process. I told you that we usually do this for many reasons. The first reason is that sometimes this material, we mix different material, cannot melt together. Like what? Like metal ceramic or metal polymer. You see that metal, for example, 1500 degrees, the melting temperature. Polymer is a few hundred. If you try to mix polymer with metal at this temperature, polymer will evaporate. Then no way to manufacturing polymer and metal together in melting. Then we bring here as a powder and mix together as a powder, and then you put here and manufacturing as a powder. Actually, let me tell you that this one made, and the mechanical properties of this one superior compared with the one made by melting. To let you know, this one really is excellent properties. I can control actually the mechanical properties. Meanwhile, this one could be controlled the porosity of the material. Porosity of the material actually, when you do compaction, it like this, it will be porous. When you do sintering, porosity will reduce. Then I can control the porosity. I can also manufacturing a porous material by powder technology. This is one reason. Another reason, sometimes you dealing with a material with very high melting temperature. Like Abdurrahman, just give me a second to finish this one and ask me. Like titanium alloy, tungsten alloy, 3500 degrees Celsius. Dealing with this material with a very high melting temperature is very difficult. So bring the material as a powder, and dealing with the material as a powder could be better than dealing with the material in the liquid, because very difficult. There are no any facility to melt material like tungsten with very high melting temperature. Yes, Abdurrahman, I'm listening.
Doctor, here, how we can get to the final shape?
Abdurrahman.
The final shape of the project, how can we get it?
Sorry, again, I didn't.
The final shape of the product, how can we get it?
Here. In the compaction, when you do compaction, actually it is here, it's kind of layout. But when you do compaction, actually you do compaction with the same shape. The shape here is that the final product shape will be in upper and upper punch and lower punch. Can you see that? the shape of the upper punch and lower punch will be exactly same like this. When you do compaction, you will get the shape in the compaction. And then you do centering. Centering, no shaping. Shaping will be done in a compaction process, Abdurrahman. Did you get it?
Yes, thank you.
It is very simplified here just to show you, but actually this one must be designed to get the shape. You get the shape in a compaction, and then you put in a furnace for centering to get the solidification strength. You get the strength. So initially you get the shape by compaction, but you get strength by centering process. Because when you do centering, you get nucleation and the material get diffusion, and then you get full dense material. You get strength by using the centering process, and finally you get the shape with the full dense after you complete the centering process. Right? Okay, this is a particular process. So what we discuss here, solidification process or casting. We discuss here a powder technology. Is the second way to shape the material. Third way to shape the material is the deformation process. Metal forming or deformation process. In metal forming, actually, we apply stress exceeding the yield stress. You know that the yield stress, if you exceed the yield stress, you get the plastic deformation. And then plastic deformation, this is what we call is a permanent deformation. So we apply stress exceeding yield stress. So we apply stress here. This is the material inside. We apply stress here exceeding yield stress. So we deform the material. So material will be deformed. This is whatever we call die. The die shape here, can you see that? Die shape here, finally the part shape we can obtain as a die shape. Actually, material here is a solid. So in the first case, in a casting process, material was liquid. Second case, the powder technology, material was powder. Third case, deformation process, material is solid. We use a solid material and we apply deformation to solid material. So we do deformation, we shaping the material. We use a die, upper die and lower die. There are a shape in upper die, shape and lower die. When we apply stress, as you can see, we shaping the material exactly as a die shape. So finally, the part will have die shape. This is whatever we call forging process. So this process, we call it forging process. This is the first one. Second process in material deformation, we call it extrusion process. Extrusion process, we apply pressure. As you can see here, we apply pressure. We apply pressure on a material. This is a material. We apply pressure material. We force the material to exit from the die opening. This is a die here. This is a die opening. So we shaping the material. See, we apply pressure. The pressure we apply pressure. We're forcing material to exit from the die opening with the shape, with the same shape of the die opening. We call it extrusion process. I would like to tell you that all this process that I'm describing here, we will discuss in details later in the coming chapters. You understand me? So here in this chapter, actually, this is the introduction. I'm just telling you what we're going to study later in the coming chapter in this subject. You understand me? So this actually no details. If you realize that there are no details, just I'm telling you, this is a forging process. We do like this. This is the extrusion process. We do like this, but there are many designs. There are many designs and many numerical details that we're going to discuss later in coming chapter. Yes, Abdullah. Listen.
Doctor, do we need to heat them
Abdullah.
first? Yes. Do we need to heat them first before applying the pressure or the force?
Okay, so I don't know. Okay, next is rolling. Rolling under material deformation. We're shaping material by rolling. So actually we're squeezing the material between the two rotating rollers. This is the two rotating roller, and we're squeezing the material between two rotating rollers to reduce the section. We're shaping the material. We call it is a rolling process. This is another process in a material deformation. Actually, there are many shaping process done here in the rolling. This is very important process in material deformation. Next is foraging process. Foraging process manually and automatically. In manually, this is a very old process done in the metal forming. Actually, it is now automated. Yeah, it's also manually. There are some people work with this kind of foraging process as a manual process still. Anyway, in the foraging process, we heating the material becomes soft, and someone hammering the material. Actually, there are a mechanical hammer now, hydraulics hammer and the mechanical, different type of mechanical hammer being used to hammering the material. When you're hammering material, we shaping the material. Actually, this is an example here. You can see that we start with this one. When you start hammering the material, when you start hammering material will be deformed. This is a die, upper die, and this is a lower die. This is the forging process. By using this is kind of advanced technology. This is a manual process. This is advanced technology by using mechanical hammer. This is the upper die, this is the lower die, and this is the details of upper and lower die. Something like this, you start hammering, then you get the final part, and then you cut here, then you get the product, this kind of scrap. So this kind of deformation done by the forging process. Again, there are no details here. I'm just telling you this is a forging process. But the forging process is a big chapter we're going to discuss in detail. I'll show you many videos related to the forging process, explain how it happened, how to design the forging process. These coming details will come later in next chapters. Right, so this is a forging process. This kind of material deformation, this is a third category in shaping process. Next is a material removal process. Material removal is a next part of the shaping process. In a material removal, actually, I remove a layer of the material. I remove layer of the material to change the geometry. Like whatever we call turning process, this is a turning process. In the turning here, we remove a layer. This one, the rotating, the workpiece rotating. This is a tool. So tool removing part of the material. Drilling, we here drill, we make hole. Here, this is the milling. We remove part of the material to to get the geometry, new geometry, or shaping the material. So we call it material removal process. Material removal, because we're removing part of the material, right? So in a material removal, we cutting and machining, and material removal, we remove part of material so you can get something. There are some holes, some area here being machined and manufacturing and so on, and finally you get something like this. Let me show you something. All right, let me share a screen. Okay, this is the removing part of material. Can you see that? We're removing part of the material here, as you can see. Part of material, again, one more time. Part of material, we're removing part of material here. When we're removing part of material here, same, you see that new geometry come. So we're shaping another one. Let me show you another one. You see that? We're removing part of material. This is the machining. Machining, we say machining, metal cutting. Metal cutting, we remove part of material. So part of material will be removed to get new dimension, new geometry, new shape, as you can see here. If you look to drilling, this is a drilling operation. Okay, so drilling here, we create hole by using drill. This is drill bit. Actually, someone will ask me what this liquid, we call it is a cutting fluid. A cutting fluid, sometime important, sometime not need. Sometime we need it, essentially we need it. Sometime we don't need it. It depends in the cutting process, what material you cut, what tool you use, and so on. And definitely this one we will discuss in detail when we come to the part of the cutting fluid. We will discuss these details. Another one also, you can see different type of machines. This is a milling process. This is a milling process. Here we remove material. Can you see that material be removed as a chip? So we remove part of the material. When we remove the material, you get the new geometry. So this is what we call is shaping. Shaping by what? By machining. So we do cutting. We call it material or metal cutting. Yes, Abdullah. Abdullah, yes, I'm listening. Okay, so this is the machining. Machining, we remove part of material. So this is a tool. We have what we call tool and workpiece. We remove part of the material to get the new geometry. So this is the machining process. So this is the machining process as we just described, right? We remove part of material to get. So waste in shaping process. Waste in shaping process. Generally, when you said shaping process, so shaping process is a 4 item. Is solidification, which is a liquid material, which is a powder, it is metal forming and metal cutting. So waste, there are no waste actually in the shaping process in the first 3 steps, which is casting, powder, and metal forming. There are no waste, but in metal cutting there are a waste. Why there are a waste in the material? Because you cut the material, you remove part of material. So because you remove part of material, you have waste of material, right? You understand? So there are some waste. So material removal process, when you say that material removal process are wasteful in unit operation, only material removal process. The other 3 the other 3 processes are not wasteful of material, because there are no waste of the material in the other 3 processes. The waste of the material in a material removal process. So material removal process, wasteful process, because we're removing part of the material. So terminology in minimum waste of the process, we have the net shape and near net shape. Net shape, actually, it means that no machining required. No machining required. Near net shape, minimum machining required. What does that mean? Actually, let me tell you that. Please listen to me carefully. Machining, which is a metal cutting or material removal process, is very, very, very important process. It could be stand-alone, and it could be consequence process after other processes, like you do casting and then you do machining. Why? Because casting process itself cannot determine the accuracy and the precision. Why? Because casting, actually, when you look to the casting, it is a liquid, and you put liquid in a cavity, and then solidification, it gets apart. When you put the liquid in a cavity, geometry will be geometry of the cavity, but when you leave it for solidification, shrinkage will happen. Shrinkage, because it is liquid and become solid, so shrinkage will happen. This is an example. When shrinkage happens, dimension will change. You cannot accurately obtain the dimension accuracy and the precision by using casting. Never. No way. So what to do? We do machining after casting. Machining is the most accurate and precise process among all shaping processes. So we need to do, we usually need to do machining after casting. We need to do machining after shaping by powder. We need to do machining after deformation as well. So usually machining is required in mostly, or let me say mostly, machining required after other processes. So some cases it is essential to have machining after the process. Some cases no need to have machining after process. It depends on what? Depends on functionality of the part. If really very precise and very accurate dimension, we need to have the machining essential and must be done after the process. But if not that very strict to get the accuracy and the precision of the part, then probably no need to have machining. So we call it is a net shape process and near net shape process. Near net shape process, it means that casting without machining, powder without machining, deformation without machining. Near net shape means that casting with machining, powder with machining, or deformation with machining. This is whatever we call near net shape and net shape and near net shape. Someone he said, ask me, why we care about that, whether we have a machining or why we just simply do machining, why we don't want to do machining. Actually, this is very important. Machining, it means that if you added machining to casting, or if you added machining to powder or deformation, it means that you added manufacturing time. It means money. You added manufacturing cost because machining costing money. So you added time, you added money because there are a technician working there are a setting to the machine, there are a consumption in the tool, and there are a time, machining time, and so all this kind of thing considered as money. Then now if you do machining, if no need for machining and you do additional machining without any need, meaning you added cost to the part, mean the part become more expensive, means that when you put in the market, you lose the market. Then if no need for machining, then you don't have to do machining. You do machining only in case of really needed. So we categorize as a net shape process and near net shape process. So if it is net shape process, just make it net shape process. But if it is near net shape and machining is required for precision and accuracy, then probably you have to do machining and try to minimize the machining as you can. Right? Is it clear? Understood? This is the waste in shaping process. Now we finish already shaping. Shaping already finished. Shaping is powder. Shaping is a casting, solidification or casting. Shaping is powder. Shaping is a metal forming. Shaping is material removal. This one already finished. We just finished the shaping process in a processing operation. Now we'll talk about property enhancement and surface processing. This is another two items in the processing. So now shaping already finished. There are no more shaping. No more shaping. خلاص يا شباب كده احنا عملنا الجيومتري. مفيش أي shaping تاني. Is there a difference between cutting and machining? Same meaning. Same meaning. Cutting mean machining. The word cutting and machining refer to same meaning. So same meaning. So process operation. So this is a shaping. Shaping already finished here. There are no more shaping. Now we talk about the property enhancement and surface processing in the processing operation. So what is that? A property enhancement, as I told you, property enhancement. This one done after shaping. So shaping already done. Then next is a processing enhancement. One of the processing enhancement, important processing enhancement, is to change the mechanical properties of the part. So spare part already we manufacturing the spare part. Already we manufacturing or we shaping the spare part, and now shape is ready. We need to change the mechanical properties. How to do? Simply do heat treatment, for example. So heat treatment operation. Heat treatment of metal. To do what? You bring the material, you heat the material up to critical temperature. When you heat the material up to critical temperature, you quenching. Quenching means you put in a water. You put in the water. When you put in the water, this is whatever immediate cooling, quenching, immediate, very high cooling rate. Then what will happen to the material? Material phase change. Material is a soft phase, change to hard phase. The material become harder. Someone said, why we don't do this one before we do machining or we do manufacturing? If you do property enhancement like heat treatment for the material, raw material, before you do material deformation or material cutting or metal cutting or machining, Means that you put the material in a hard phase and then you do machining or your material deformation. It's very difficult. You make it difficult for yourself. It's better to do shaping while material in a soft phase. We use the material in the soft phase and do machining. تمام? We use the material in the soft phase and do machining, cutting or deformation. And then after you do shaping and after you finish shaping, because it is easy. Is a material in the soft phase, it is easy to do the machining process. And after you finish, you bring it to the heat treatment and then you change the material properly to the hard phase, so material become hard. The material can serve the service life or the material life or the part life will be longer because you make material harder, then it work better in the working environment or condition environment. Also, you talk to me, Abdullah. Abdullah, you talk to me, speak in phone. I don't know. He said that is the heat treatment affect shaping. No, heat treatment not affecting shaping, Abdullah, because heat treatment, you heating the material. Shape already done in a shaping process. There are no shaping in a heat treatment on property or on property enhancement process. There are no shaping here. Shaping done already before in the previous steps, but some distortion could happen. It's not shaping, no shaping, but some distortion due to heating. When you heat the material, you know that when you're heating the material expands, and then when you're cooling it, it's contract. So between the expansion and contraction, this kind of some distortion could happen. But no shaping. This is no shaping. Shaping means you change geometry as a design. We design certain geometry, we change geometry based on the design or the pre-designed process. There are no shaping done previously, right? So heat treatment not affecting the shape or geometry at all, right? Another process is a sintering process in a powder. If you remember, in the powder we do compaction and sintering. We do compaction, we apply pressure in a bunch, upper bunch and lower bunch to create the shape done in a compaction process. But when you put in the sintering, you do what? You do property enhancement. Because we do sintering process, when you do heating, nucleus will happen, as you can see here. When you do heating, nucleus will happen. When you raise the temperature up to 70% or something of the melting temperature, nucleation will happen, diffusion will happen. Diffusion will happen mean the material become full dense. Then you do property enhancement in a sintering process of the powder technology. So heat treatment process, sintering process in the powder technology, both contribute to, for example, to do property enhancement of the product. Why I said product, right? Next is the surface processing. It's another process in a processing operation, which is a surface operation or surface processing. Actually, this one deals with the surface, as I told you. So this is a surface. This surface, after you do property enhancement, even it is subject to environment, subject to the environment. So what? Environment could be, for example, humid environment. This is an example. For example, if you use or you manufacturing a part made of steel, if you're manufacturing part made of steel, and this part going to be used in environment or humid environment, with high humidity ratio, and then attack steel, and then steel will rust. Then if you leave it for a few weeks or few months, this one will be totally damaged, totally destroyed. Then you need to protect. Why surface? Because surface, if you protect the surface protecting whatever it is below. Because the surface is the boundary. So what is the surface processing? Surface processing like painting. See here? Painting, if you bring paint here and you painting surface, this paint covers the surface, probably protect the surface from the environment, from the humidity, or from the other whatever other factors could affect or could damage the surface. And finally, you protect the surface, you protect the material. It can work for a long time. So first step is a cleaning. You clean the surface. Second step is the surface treatment, mechanical working such as sandblasting and physical process. Actually, we will discuss this one in details when we come to this one. Sandblasting and physical process to remove the dust and remove the contamination and so on. And then coating, thin film deposition, or painting like electroplating or painting. We do electroplating, put other material on the surface, or we do paint. It could be painting or electroplating, and finally you protect the surface from the environment. Right? Is it clear? Any question? I'm listening. Any question, guys? Is it clear? You understand? Right.
Yes, clear.
If no question, meaning okay. Right. Just move forward. This is a processing operation. So processing operation. Okay, Khalid, thank you. Processing operation is a shaping process. This is the 4 item in the shaping process. Property enhancement, like heat treatment and sintering process in powder technology. Surface processing operation, cleaning and then coating or painting or electroplating. This is the item of processing operation, already finished. And now we're discussing now about the assembly operation. Assembly operation, we have a permanent joint, we have a mechanical joint. Permanent joint and mechanical joint. Let's see together. This is the assembly operation. We have joining mechanical, joining and mechanical. Joining process, which is a permanent, like welding. Here this guy do welding operation. When do welding operation, become one part. When you do welding operations, the 2 parts become 1 part. Very difficult to disassemble again. In the welding, we have welding, brazing, soldering, adhesion, bonding. This is all category in welding. We will discuss this kind of processes in details when we come to the welding chapter. But anyway, finally, when you do welding, become 1 part, it's very difficult to disassemble again. We call it permanent joint. Permanent joint. The second method is the mechanical assembly, which is a bolt and nut. Bolt and nut, when you have bolt and nut, you will have ability to assemble and easily also disassemble. If I ask you which one is better, to do permanent joint or to do mechanical assembly, I can answer actually. I can say that both are very important. No one better than other. Some cases, permanent joint is essential. And some other cases, mechanical assembly is very essential, and we cannot do permanent joint. It depends on what? It depends on the case. So case by case, we have to deal with the processes case by case. Some cases require permanent joint, some cases require mechanical assembly. Right. Let me, can you please repeat mechanical assembly? لو حد عايز يسألني يا شباب يسألني بالصوت أسهل بدل ما تكتبوا لي يعني. ميكانيكال اسمبلي يا ناصر يعني بولت اند نت. وي يوز بولت اند نت. دلوقتي انت هتفهم لما انا هوريك. خليك معايا. انا هختم المحاضره دي بالفيديو ده. هختم المحاضره دي بالفيديو ده. هيوريكم الاسمبلي، الميكانيكال اسمبلي. هو مش هياخد حاجه، هو مش فيديو كبير. ده يا شباب زي ما انتم شايفين. سامعيني يا شباب؟
اي سامعينك دكتور.
سامعيني؟
ايوه ايوه
يس
واضح
واضح دكتور.
سامعيني بقول؟ تمام. ده الفيديو ده تمام. تمام. ده الفيديو ده بيبين الاسمبلي بتاع الكار انجن. ده الكار انجن حقيقة زي ما انتم شايفين كده. دي الفالفز زي ما انتم شايفين كده، دي الفالفز بتاع الكار انجن، ودي بتتربط كلها بالمسامير. يعني ده الميكانيكال فاستنج، ده اللي انا بقول عليه الميكانيكال. يعني كان في حد بيسالني، وده الكام شافت، وده الجاسكت. ده الجزء ده بيركب على الجزء بتاع الانجن ده بالمسامير، ودي كل دي بتركب بالمسامير زي ما انتم شايفين كده. فالاسمبلي هنا you can see the assembly. This is the mechanical fastening process, all done by using bolt and nut. All done here by using bolt and nut. This is the cover. We put the cover and sealing put here, all done by bolt and nut. This is the oil reservoir, because oil accumulated here, and then we put below, so it is being used to accumulate oil for recycling to bring back again. Different part in a car engine being assembled by bolt and nut. This is the example of mechanical assembly. Can you see that? So the question is, why mechanical assembly? Why we didn't just do welding? Is it okay to do welding here? Yes, can. But if we do welding, what will happen? If something wrong happened to the engine inside, will very difficult to disassemble again to fix the problem. يعني نتكلم بالعربي، لو انت عملته باللحام، لو انت تخيل ان انت عملت الاسمبلي ده بتاع الانجن باللحام، لو باظ حاجة جوه، لو في جزء من الاجزاء في الانجن في الداخل باظ، هتجيبه ازاي؟ هتغيره ازاي؟ No way to change. You have to have it, or to us here. This is cycle, as you can see here. This is the car engine cycle. Enjoying, huh? فهنا زي ما انتم شايفين كده يا شباب، مهم جدا. In this case, I give you here an example. So in this case, as you can see, in this case, mechanical assembly is very essential. We cannot do permanent join, because if you do permanent join, it means that what will happen, very difficult to disassemble for maintenance. But some other cases, like as you can see here, this is a pipeline, for example, the oil pipeline. Welding is very important. You cannot do mechanical fastening, because welding here, when we do welding process here, this one stop leakage of the liquid, and also we need strength. We need a high strength. So in this case, for example, welding is very essential. So now I show you two cases. One case for the engine, another case for the pipeline in the oil pipeline or whatever pipeline, and so on. But there are many other cases in industry, and every case have different condition. Okay, this is time is just finished, so I will stop